Okay, welcome to a new series where we learn about SimpleFSDP. So in this lecture, I just want to give a high conceptual overview of what SimpleFSDP is. And then the next lectures, we'll talk about how it composes with other forms of parallelism and how it's actually implemented in code. Okay, so at a high level, what is SimpleFSDP? SimpleFSDP is a compiler-friendly way to implement FSDP, which stands for Fully Sharded Data Parallel. And what does Fully Sharded Data Parallel mean? Fully Sharded Data Parallel is a way to train neural networks across many GPUs. And in this example, we have 2 GPUs to prove the point. The basic idea is that, typically when you have a neural network, you store all the weights in your GPU memory, and then you allocate some tensors on your GPU as input, and you run it through, and you have your output, and you do backpropagation. The idea behind SimpleFSDP is that you can shard the weights of your model across GPUs, and you do it layer by layer. And basically the idea is before you do the compute of the layer, you do an all gather, where basically every single GPU shares the weights of the particular layer with each other and kind of materializes the full layer so you can do the compute. And so this is kind of what I've drawn here, where if you have 2 GPUs, maybe for each layer you store half the weights on one GPU and half the weights on the other. And then when the input comes for layer 1, you do an all gather, you do a communication, you bring all the weights together, you do your compute, and then you go to layer 2. And then layer 2, you do an all gather again to gather the weights. And then critically, you actually drop the extra weights from layer 1 that you don't need. And so this allows you to basically keep memory usage down and then kind of grow your model. And what's interesting is that if you do things well, you actually don't pay too much of a cost for this communication, because you can do what's called compute communication overlap. And so the basic idea is, for example, when you're doing the computation for layer 1, maybe you're doing a bunch of matmols, you can actually in parallel kick off prefetches for the parameters of the next X layers. And then so by the time you get to layer 2, you actually don't necessarily need to do a blocking communication. Maybe the communication has already come back in time and you can kind of do the compute. And what's interesting is maybe before you do the compute of layer 2, you kick off a few more prefetches, for future layers. Okay, so where does the symbol come in? The symbol comes in because FSDP was originally implemented in an eager way in FSDP 1 and 2. We won't get too much into that, but the basic idea behind SimpleFSDP is that it's a lot more compiler friendly. In particular, we can capture the entire graph using torch.compile, and then we can use compiler FX passes to optimize. We can optimize by basically looking at the nodes of the graph and then bucketing communications together and reordering it to kind of hide as much what they call exposed communications as possible. We're going to go into more detail, but I will call out that there's actually a paper on SimpleFSDP written by Racy, which is really great. And in particular, they have these diagrams, which kind of build a lot more intuition as to what's going on. So I just want to call that out. But yeah, that's all I want to talk about today. In future lectures, we'll go into a lot more detail, but hopefully this gives you a high-level overview of SimpleFSDP and will serve as a good primer for the following lectures.